Gate exam questions with solutions in power systems, part 3. Question number 11. The per unit power output of silent pole generator which is connected to infinite bus is given by the expression P equal to 1.4 sin del plus 0.15 sin 2 del, where del is the load angle, and Newton-Raphson method is used to calculate the value of del for P equal to 0.8 per unit. If the initial guess of this del value is 30 degree, then its value at the end of the first iteration is asked in this question. Solution. So, the given value P is equal to 0.8 per unit and the expression is P is equal to 1.4 sin del plus 0.15 sin 2 del. So, we can equate this. So, 0.8 equal to 1.4 sin del plus 0.15 sin 2 del. Now, the function of del will be equal to this whole equation. Taking this 0.8 to this side, it becomes minus 0.8. So, f of del equal to 1.4 sin del plus 0.15 sin 2 del minus 0.8. By Newton-Raphson method, del 1 is equal to the initial angle del naught minus the function of the initial angle del naught divided by the derivative of the function del naught. So, the function is f of del equal to this equation. So, substituting that equation over here and substituting the value of del as 30 degree which is given in the problem, and del naught equal to 30 degree, converting the degree into radian, we are multiplying that 30 degree into pi divided by 180 minus the function of del naught f of del. So, 1.4 into sin del is 30 degree, 0.15 sin 2 into del, 2 into 30 degree is 60 degree minus 0.8 divided by the derivative f dash of del naught. The differentiation of this equation is 1.4, sin del differentiation is cos del, so cos 30 degree plus 2 into 0.15 cos 2 del. So, 2 into 0.15 into cos 2 into 30. And now, by simplifying this, we will be getting 0.523598 minus the upper part 0.0299 divided by the denominator is 1.3624. Simplifying, we will be getting del 1 equal to 0.50165 radiant. So, converting this radiant into a degree mode, so we will be multiplying with 180 divided by pi, that gives you del 1 equal to 28.74 degree. So, the correct answer is 28.74 degree. So, now we move on to the next question, question number 12. So, here the positive, negative and zero sequence impedances of a 3-phase generator are Z1, Z2 and Z0 respectively, and for a line to line fault with fault impedance ZF, the fault current is given as IF1 equal to K into IF, where this IF is the fault current with zero fault impedance, and the relation between this ZF and K is asked in this question, and the options are given like this. Solution. For a line to line fault, the fault current expression will be IF equal to root 3 divided by Z1 plus Z2, positive and negative sequence impedance. So, in the line to line fault, there is no zero sequence impedance present in the fault current expression. And now, the fault current with the fault impedance, we name that as IF1, that will be equal to root 3 divided by Z1 plus Z2 plus the fault impedance ZF. Now, in the question it is given IF1 equal to K into IF. So, substituting IF and IF1 from the previous expression. So, IF1 is root 3 divided by Z1, Z2 plus ZF equal to K into IF. IF is root 3 divided by Z1 plus ZF. So, root 3 and root 3 get cancelled. Remaining term, you multiply this whole term to that side and this Z1 and Z2 to this side. So, Z1 plus Z2 into K plus ZF into K, that will be equal to Z1 plus Z2. Now, ZF into K is equal to Z1, Z2 this side, and taking this K to this side, it becomes minus K. So, taking Z1 plus Z2 as common, we will be getting 1 minus K this side. So, ZF equal to Z1 plus Z2 into 1 minus K divided by this K. So the correct option is A, ZF equal to Z1 plus Z2 into 1 minus K divided by K. So we move on to the next question, question number 13. So a 3-bus power system is given in the problem where the diagonal elements of Y bus matrix, that is Y11, is given as minus 12 per unit, and Y22 is minus 15 per unit, and Y33 is minus 7 per unit. Okay, and the diagram is given. The per unit value of line reactances or P, Q and R, which is shown in the figure, that we need to find. So the line reactance P, Q and R. So the options are given like this. So the given data consists of all the diagonal elements of the Y bus matrix. Using that data, we need to find the line reactances. Solution. So consider this diagram, and the self admittances Y11 can be represented as small y10, y12 and y13. That will be equal to minus J12, which is specified in the problem. So the lines which is connected to bus 1 will be considered here. So in the bus 1, the two lines are connected. One is JQ and JR. Okay, so this two line reactances, the negative of these two line reactances, that gives you the answer for Y11. So that is minus JQ dash plus JR dash. That will be equal to minus J12. We can rearrange and write this equation as Q dash plus R dash, that will be equal to plus 12. This is the first equation. Similarly, for the self admittance Y22 for the bus 2, that will be equal to minus J15, which is given in the problem, that will be equal to Y20 plus Y21 plus Y23. Y20 is not given, and Y21 and 23. So this 21 and 23. There are two lines are connected to bus 2, and we can write that as minus JQ dash plus JP dash. So now rearranging that, it becomes P dash plus Q dash equal to plus 15. So minus and minus get cancelled and J get cancelled. So this is your second equation. Similarly, for the third bus Y33, that will be equal to minus J7, and in third bus two lines are connected, R and P. So P dash plus R dash, that will be equal to plus 7. Minus get cancelled here. So this is the third equation. Simply solve these three equations and you can get P equal to plus 5, Q equal to plus 10 and R equal to plus 2. And these and all the admittances, since we are directly calculating from the Y bus, these and all admittances. But in the question it is asked to find the reactance of the lines. So simply by taking inverse of this admittance, you will be getting the reactance. So 1 by 5 is 0.2 and 1 by 10 is 0.1 and 1 by 2 is 0.5. So this is your answer. So the correct option is B, P equal to 0.2, Q equal to 0.1 and R equal to 0.5. So now we move on to the next question. Question number 14. So the bus admittance matrix for the power system network is shown. Here it is a 3 cross 3 matrix. So it is a 3-bus system, and there is a transmission line which is connected between buses 1 and 3, which is represented by the circuit. So the two bus alone shown here, 1 and 3. The reactance connected between bus 1 and 3 are 0.05 per unit, and the line charging susceptance is given as 0.05 per unit in the both the ends of the line. So if this transmission line is removed from service, so the condition is very important. If this transmission line of reactance 0.05 is removed from the service, what changes occur in the Y bus matrix? So what is the modified bus admittance matrix is asked in this question. So these are the options. So solution. So consider this diagram. Under the Y bus matrix is of the 3 cross 3 matrix, Y11, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3 and 3, 1, 3, 2 and 3, 3. So when the line 1 and 3 is removed, the 3 values will change in this Y bus matrix. So first one is Y11 will change and Y13 y33 will change and y13 will change. Okay, so these three values will change in this y bus matrix. So remaining elements remain unchanged. So first one y11. So y11 new value will be equal to y11 old minus y13, the line connected, the admittance of the line connected between 1 and 3, minus the line charging susceptance, shunt susceptance. So it is a half line charging susceptance, H is H13. So now y13 equal to minus small y13, the admittances connected between line 1 and 3, that will be equal to minus 1 by the reactance. So reactance is specified in the question is 0.05. So minus 1 divided by 0.05, that gives you minus J20. So that is your y13, and the second is H13, half lines shunt susceptance, that is given as 0.05 in the problem, and in the diagram also you can able to see, and you can substitute these two values and y11 old from the given matrix. So you can take that is minus J39.9, and this is minus of minus J20 y13, and H13 is minus J0.05. So substituting this value, calculating, you will be getting minus J19.95. So the y1 new is minus J19.95. Similarly, the second term is y33. So the same thing here also, y33 new equal to y33 old minus y31 minus H31. So the same value here also, the line reactance is 0.05. So you will be getting minus J20, and half line shunt susceptance is 0.05. So you can substitute that value, you will be getting minus J19.95. And the third value is y13. So the line 13 is removed now. The modified case, the y13 is removed. So y13 is equal to y31, that value will be equal to 0. Okay, so the modified y bus matrix will be, so y11 changed from minus 39.9 to minus 19.95. Similarly, y33 changed to minus 19.95, and this y13 and y31 become 0. So this is the final expression. The correct option is option C. Now we move on to the next question, question number 15. So a 3-bus power system network consists of 3 transmission lines, and the bus admittance matrix of the uncompensated system is given in the problem, which is minus J6, J3, J4 and J3, minus J7, J5, J4, and here also J5, it's a printing mistake, and minus J8 per unit. And if the shunt capacitance of all the transmission line is 50% compensated, the imaginary part of third row, third column element of the bus admittance matrix after compensation is asked in this question. So that is third row, third column, that means y33, the imaginary part of y33 is asked when the lines are 50% compensated. The given y bus is uncompensated system. So we need to assume the compensation, 50% compensation, and find y33. So the options are given here. Solution. So y bus matrix, as you know, here it is a 3-bus system, so 3 cross 3 matrix, and this y bus, so the diagonal element will be y11 plus y12 plus y13. In some cases we can consider this as y10 also, and here it is y20, and here it is y30, or we can simply take like this, and the half diagonal element remain minus y12 minus y13. Similarly, all the half diagonal element are represented as minus, and the given value is this one, minus J6, J3, J4, J3, minus J7, J5, J4, J5 and minus J8. So we need to concentrate only on this y33. Okay, so we need to find the new value of y33 for the compensated line. So y33 equal to y31 plus y32 plus y33, that will be equal to minus j8. So substituting y31 and 32 value from the matrix, so y31 value is j4 minus j4. Okay, since it is minus y31 here, so j4 is the answer, so minus comes here, so it becomes minus j4, and y32, 32 is j5, so it is minus j5 plus y33, this is what we are going to find, that will be equal to minus j8. So taking this minus j4 and j5 to that side, it becomes plus j4 and j5, so we will be getting this value, so 9 minus 8 is 1. So y33 equal to 1j. Now after 50% compensation with the shunt capacitance, what happens? This y33 can be multiplied with half value, so 50%. So that to represent that, it is multiplied with 1 by 2. So that gives you j into 0.5. So y33 new equal to y33 old minus this y33 with 50% compensation. So y33 new equal to old value, the given value is j8, that is minus j8 minus of this j0.5. So that gives you y33 new equal to minus j8.5. So the correct option is B, minus j8.5.